Okay, welcome to this video. We're going to look at another aspect of the CuePython package, in this case, server schedules. So maybe servers are not actually available all of the time, but maybe they are available according to some fixed schedule. So that's what we're exploring here in this video. So let's start with going through the implementation. Here we've got import Q, because of course we're using the Q package. What else would we do? We'll get back to this warning, but the gist of it is when you're in the current state of Q, according to the documentation, and maybe we'll experiment with this in this video later. Yeah, we probably will. But you cannot have infinite servers with server scheduling, unfortunately. So if you think about the default behavior of Q is that some integer number of servers is specified, and that's exactly how many there are for ever and all time, or at least in the simulation all of the time. But here we get to actually say that there's going to be a sequence of number of servers that will be available. There's first going to be 2 servers available, and then 0 servers available, and then 1 server available. And there are these, what they're calling shifts, where from time 0 to 10, there will be 2 available, right? There's going to be corresponding elements here. There's 10, or 0 to 10, time 10, there will be 2, and then from 10 to 30, there will be 0. And then from time 30 to 100, there will be 1 server. Okay? So it's defining these intervals tacitly, all with respect to time equals 0. How you define the schedule object here is with q.schedule, and you pass in the number of servers, and then the shift and dates. Okay, so it is another class to define. Excuse me. So we'll define a network here, as usual with the Q create network constructor. So we've got arrival distributions, and here we're doing the most boring thing here, basically an MMQ for the arrivals, exponential and exponential. And here the service rate's a bit higher. I don't know that it matters too much, but yeah, anyway. So, number of servers. We pass in, instead of a fixed integer, we pass in schedule object, and there's internal logic that knows how to look up these pieces of information and how to use them. Now, if we get to running a simulation, I mean, hopefully if you've watched some of the earlier videos, this should all be very routine now. We're going to define a seed number, in this case 2025. It just happens to be the current year, whatever. And simulation initialization with our choice of network, and we'll run the simulation, in this case for 205 units of time. Notice that will cover the 100, so we should actually see all the shifts complete. Now, what happens if we get past time 100? The way that Q works with these schedules is it'll loop it back around. So when you finish from going from 30 to 100, you'll get back to what was the 0 to 10 behavior, but for the interval of 100 up to 110, and then likewise there will be 0 for 110 up until 130, and it just goes round and round. It's a modular clock. Okay, so we're going to simulate for 205 just to cover more behavior. All right, and then we'll grab the records just to take a look. And the point that they wanted to make from the documentation here is just to show that, look, from 10 to 30, you should have 0, and that from 110 up to and not including 130, you should again have 0. So let's run this simulation. What we got here, we got server schedules, and we get empty lists, as we should expect, that the number of servers available during those periods of time, and hence whether or not any service completion gets completed in those intervals, should be empty, and it is in fact empty. Okay, so that's actually the main gist of this, is to say you wanted to plan out some kind of schedule. What if you don't want cycling behavior, right? We mentioned like the 10, 30, 100. What if you don't want it? I'm not sure that you can put an infinity in here, but what you can definitely do is just plan out the schedules for the units of time out until beyond your simulation period that you care about, or at least up to then, so that you get all of the desired behavior that you want, so that you never actually repeat it. Okay? All right. So let's try to set, just for the sake of honestly my curiosity, let's try to set float infinity here for the 0 to 100, and I'm expecting we get an error. Yeah, okay, we get an error. Oh yeah, there's a range object somewhere in the node class. I see. Okay, so that's why. So right now it's currently a loop, but you can't create a range generator sequence from a non-integer. Okay, so that explains that one. Now the other thing I was curious about, maybe we can set infinite for this, which is after all a float. Does it just continue on instead? Let's try it out. There we go. Okay, so I think that this is, if I'm interpreting it right, that you'll just continue on with that final piece of scheduling forever. Now let's do a silly thing we shouldn't do, just to see what the behavior is. Does it create services there or not? Does not. So that makes sense, because that's the one where it should be basically 0 on and on. That interval. What if we broke it here? We want float infinity, and then we're back to, well, it just stays in that first period. Okay, so you can include infinities for the shift end dates, which I don't know, that's up to you on whether that makes sense for your problem. Okay, I think that's all I wanted to cover in this video. Hopefully that sets you up for creating schedules, which for some types of simulations of industrial processes or workflows, or things like availability of nurses and doctors and stuff that are sometimes shift based, that should hopefully give you at least a good starting point. All right, with that, I will catch you in the next video. Take care.